Hello and welcome to this lesson on alkanes. Today, our lesson will focus on understanding the process of complete combustion of alkanes. We will then explore the process of incomplete combustion. So far, you've become familiar with alkanes and their properties. You know that alkanes are organic compounds consisting of hydrogen and carbon atoms bonded together by single bonds. Building on this foundation, today's lesson will expand our chemical understanding by exploring how hydrocarbons undergo complete combustion and the chemical reactions involved. Let's get started! When a substance burns in the presence of oxygen gas, this process is called combustion. When it comes to hydrocarbons, combustion can occur in two ways: complete combustion and incomplete combustion, depending on the amount of oxygen available. In complete combustion, the hydrocarbon reacts fully with oxygen to produce two main products, carbon dioxide and water. This occurs when there is plenty of oxygen and every carbon atom in the alkyne is fully oxidized. Oxidation in this context means that the carbon and hydrogen atoms in the hydrocarbon gain oxygen atoms. One important thing to note is that complete combustion is an exothermic reaction, meaning it releases heat energy into the surroundings. If you've ever warmed your hands by a fire, you've experienced the heat released from the exothermic combustion of fuel. This is why fuels like propane and gasoline are so valuable. They release a large amount of energy when they burn completely. The general word equation for complete combustion is alkane plus oxygen produces carbon dioxide and water. Let's consider the combustion of methane. Remember that the meth prefix means one, so methane is the alkene with only one carbon atom, meaning it must be CH4. We can thus write the equation. CH4 plus O2 produces CO2 plus H2O. We now need to balance this equation. Pause this video and have a try at balancing it yourself. Here's what it looks like balanced. The equation shows that one molecule of methane reacts with two molecules of oxygen to produce one molecule of carbon dioxide and two molecules of water. When there isn't enough oxygen present during combustion, the reaction produces carbon monoxide instead of carbon dioxide. This is called incomplete combustion. The word equation for this is alkane plus oxygen produces carbon monoxide plus water. For example, when methane burns with insufficient oxygen, the reaction goes as follows. Methane plus oxygen produces carbon monoxide and water. If even less oxygen is available, the reaction leads to the formation of carbon, soot, alongside water. The presence of carbon particles causes the flame to appear smoky and black. The word equation for this process is alkene plus oxygen produces carbon, soot, plus water. Incomplete combustion is not only less efficient, but also dangerous. The carbon monoxide formed is a colorless, odorless gas that is highly toxic because it prevents the blood from carrying oxygen. Prolonged exposure to carbon monoxide can lead to poisoning, with symptoms including dizziness, confusion, and in severe cases, death. Furthermore, the carbon, soot, produced can cause respiratory issues and contributes to air pollution. Hence, it's important to ensure proper ventilation when burning hydrocarbons. In today's lesson, we delved into the complete combustion of hydrocarbons, focusing on how these compounds react with oxygen. We learned that during complete combustion, hydrocarbons fully react with oxygen to produce carbon dioxide and water, releasing significant heat energy in the process. We also learned about incomplete combustion where carbon monoxide or carbon, soot, are produced. By grasping these concepts, we gain insight into energy production and the environmental impact of burning fuels, forming a critical foundation for further studies in organic chemistry and environmental science. Watch the rest of the GCSE chemistry course at Sophos Education.